According to 𝗬𝗏, an eminent geophysicist, our knowledge of the oceans is still fragmentary and inadequate. In the Pacific and the Indian Oceans, there are large regions from which no information is available, and from most areas only general conditions in certain seasons of the year are known. However, with the help of improved technology and artificial satellites, it may be possible to fill the gaps in the future. It is true that for the proper appreciation of our present knowledge of the oceans, it would be advisable to peep into the remote past. It must be borne into mind that whatever knowledge we have gained about our oceans, it is all due to the rapid progress made in various scientific disciplines. We will certainly be benefited from surveying the early history of the investigation of the conditions existing in the oceans. However, contributions made by great explorers towards gaining more information about the oceans, hitherto unknown, cannot be overemphasized. Despite limited resources at their disposal, the great explorers like Columbus, Captain Cook, Magellan, Vasco da Gama, and many more undertook perilous world voyages without caring for their lives. After this lesson, you will be able to understand the origin and the development of oceanography from the Greeks to the modern times, and will learn about new expeditions. It is true that the foundation of the present discipline of oceanography was laid much earlier in the classical period, but its development as a systematic science began in the 19th century. Herdman has rightly remarked oceanography is a subject of modern development, though of ancient origin. There is little doubt that during the classical period, the Greeks and the Roman philosophers, cum scientists, lacked correct information about the entire globe. The knowledge of the outside world was limited to the boundaries of the Mediterranean Sea. Even though they had established contacts with many countries prior to the 15th century, the expansion of their knowledge was rather slow. The activities of the Greeks were restricted to the coastal countries of the Mediterranean Sea. Since there were no necessary apparatus and equipment for open ocean navigation, they both were always kept close to the shore of the sea. During the night time, the navigators had no other means to know the direction except the stars in the sky. Moreover, people in those days were highly superstitious and had a lot of absurd ideas about the oceans. People living in the coastal areas turned their eyes towards the sea for the sake of getting food from it and developed familiarity with it. Fishery was the main occupation. Slowly and gradually, they improved their boats in which they could sail farther than before. With the gradual development of civilization, vessels were built which could move upon the ocean surface. Thus, people could make contact with distant societies. The Phoenicians were the first Westerners to have developed the art of navigation. The recorded history tells us that as long ago as 2000 BC, those people started sailing in the boat over the Mediterranean Sea, the Red Sea, and the Indian Ocean. The Phoenicians established trade with the countries of Southeast Asia. They discovered the Canary Islands located in the Atlantic Ocean. By 590 BC, some of the Phoenician sailors circumnavigated Africa. They sailed up to Great Britain. For the ancient Greeks, Okeanos, which stood for the ocean, was the great stream supposed to enclose the Earth's disk, the Atlantic Ocean, the great outer sea beyond the Pillars of Hercules. Aristotle, in his famous book 𝗦𝗏, has discussed the interactions between the ocean and the atmosphere. In his treatise, he has described various phenomena like evaporation, condensation, and precipitation. Thus, he clearly gave an idea of the hydrological cycle. However, the credit is given, though wrongly, to another great philosopher, Anaxagoras, for introducing the concept of hydrological cycle. There is no denying the fact that during this period of development, oceanography, the contribution to the Greeks and Romans was praiseworthy. Herodotus constructed a world map, and in 490 BC, which the Greek civilization has been shown to have centered around the Mediterranean Sea. three continents of Europe, Asia and Libya have been shown to lie to the northeast and the south respectively, surrounded by three major seas, Mare Atlanticum to the west and Mare Australis to the south and Mare Erythraeum to the southeast. The most interesting thing about this map is the fact that the north and the northeastern margins of the continents of Europe and Asia are indicated as unknown, but it was the belief of the Greek philosophers that the oceans represented a margin of water enclosing all the three continents as stated above. The Greek astronomer Pythias sailed to the Iceland in 320 BC. It was this astronomer cum geographer who, for the first time, on the basis of the astronomical measurements, evolved a method for finding out the latitude of a place. He also hypothesized that the tides were produced in the oceans only because of the attraction of the moon. Another Greek philosopher, Eratosthenes, was the first mathematician to have calculated the circumference of the earth. According to his calculations, the circumference was found to be 40,000 kilometers, a figure that is slightly different from the actual circumference of the earth, that is 40,032 kilometers. Strabo and Seneca, the two Romans, made valuable contributions towards a geographical knowledge. Strabo had observed the volcanic activity and concluded that the land periodically sank and rose as a result of this activity. As a result of the volcanic activity, the sinking of the land caused the sea to invade the land, whereas the rise in the land made it to recede from the continent. He also threw light on the process of river erosion. Seneca, on the other hand, introduced an altogether new concept known as hydrological cycle. He also made us familiar with the fact of continuous evaporation from the sea surface. Ptolemy, another Roman philosopher, in AD 150, prepared a map of the world that showed the Roman knowledge of the world at that time. For the first time, the grids of the latitude and longitude were drawn on his map. Mariners could determine the latitude of any place on a surface of the earth using the method evolved by Pythias. On the map, the Indian Ocean was shown as being surrounded by an unknown landmass. Ptolemy's map indicated the continent of Europe, Asia and Africa. All the oceans were considered to have boundaries defined by unknown landmasses. Post the Greeks and the Romans, period of the Dark Age ensued. Following that, we had few discoveries by the Chinese and the Indians and Arabs. This was followed by the contributions of discoverers in the 16th century, which is also called the Age of Discovery, by various greats like Vasco da Gama, Columbus and Ferdinand Magellan. The development of oceanography as a systematic science actually began in the 19th century. Excepting the polar areas, the distribution pattern on the land and water on the globe became well known by the beginning of the 19th century. Voyages undertaken during that century devoted most of their time in the investigation of the biological and chemical properties of the ocean, the morphology of the sea floor and the currents that move through it. The following is a brief discussion on the contributions of eminent explorers and oceanographers to the development of this branch of the science. Charles Wilkes. The United States exploring expedition was launched in 1838 under the leadership of Lieutenant Charles Wilkes, U.S. naval officer. The expedition comprised of 6 persons, including a flagship Vincennes. The scientists aboard were reputable professors of natural sciences in America. The expedition left the United States coast on a 4-year circumnavigation. The expedition's mission was pure exploration and its objective was mineral gathering, charting and observing. However, there was a peculiar goal to unfold the mysteries shrouding a peculiar theory that the earth was hollow and could be entered through huge holes at either poles. The expedition disproved this. The scientists comprising the expedition's team for the first time explored and charted a large part of the East Antarctic coast and confirmed that the landmass was a continent. Expedition team also explored Hawaii Islands. Wilkes led an ascent of Mount Loa, one of the 2 peaks of the island's tallest volcano. Dana, a geologist member of the expedition team, confirmed the theory of Charles Darwin regarding the formation of the coral atoll. The expedition also disproved the hypothesis of the so-called polar holes. The expedition returned home in 1842 with many scientific specimens and artifacts which were kept in Smithsonian Institute in the Washington, D.C. The expedition's reports were published in 19 volumes of the maps, text and illustrations. It is undoubtedly a landmark in the scientific achievement of America. It has been aptly remarked that had it not been for the combating and disagreeable personality of its leader, Lieutenant Charles Wilkes, the expedition might have become as famous as those of Cook and later Challenge Your Voyage. Matthew Fontaine Maury. Maury was an officer in the United States Navy in charge of the Department of Naval Charts and Instruments. Maury had a large number of logbooks in which depot which were full of useful information about the ocean currents and weather conditions in different parts of the oceans. After a careful and systematic analysis of these logs, Maury prepared several charts containing wind and current patterns. Such charts proved very helpful to the explorers of the 19th century. Credit is given to Maury to initiate the organization of the first International Oceanographic Conference in Brussels in 1853. That conference had on its agenda the task of bringing uniformity in the methods of making nautical and meteorological observations at sea. Maury for the first time wrote The Physical Geography of the Sea in 1855, which proved to be a milestone in the development of oceanography as a systematic science. Charles Darwin. Darwin was an eminent scientist of the 19th century who had taken keen interest in the natural history. This young scientist circumnavigated the world on a ship called HMS Beagle. During his voyage, he gathered vast store of data from observations which are of great help to reach his conclusions regarding evolution by natural selection. He surveyed the coasts of Patagonia and Tierra del Fuego in 1831 and made observations of plants and animals in different environments. On the basis of his observation, Darwin wrote The Origin of Species, a book of world fame. In this book, he propounded the theory of natural selection. He closely watched the changes that took place in the flora and fauna in different environments. He arrived at the conclusion that changes occurred slowly over a long period of time represented by geological past. However, Darwin's ideas were highly controversial, but his many ideas can be proved on scientific basis. Sir John Ross and Sir James Clark Ross. The Rosses were Englishmen and they succeeded in sounding the deep ocean basins. John Ross performed the most difficult task of measuring the depth of Baffin Bay. James Clark Ross, on his voyage to Antarctica from 1839 to 1843, successfully measured a greater depth of 7 kilometers. He observed that there was a great similarity between the animals recovered from the cold waters of Antarctic and those recovered from the Arctic Ocean. So he arrived at the conclusion that waters filling the deep ocean basins must be of uniformly low temperature. The Challenger expedition. The controversy about the distribution of life in the ocean prompted the Royal Society to organize a scientific expedition which would investigate the following: the distribution of the organic life, plant as well as animals, in different depth zones in the oceans and on the ocean bottom, the physical conditions of the deep sea in the great ocean basins, the chemical composition of seawater at various depths in the ocean, and the physical and chemical characteristics of the marine deposits of the ocean bottom and the nature of their origin. In December 1872, C. Weil Thompson, the director of the expedition, left England on the HMS Challenger ship. He was accompanied by a staff of 6 scientists who were specialists in different branches of science. Having thoroughly surveyed large portions of Atlantic and Pacific Oceans, the Challenger returned in May 1876. The Challenger expedition had great achievements to its credit. The expedition covered a distance of 1,27,500 kilometers and sounded 492 deep ocean basins. It procured 133 samples of marine deposits. Another important contribution of this expedition was to gather detailed knowledge of the origin and structure of the coral reefs and the mapping of the distribution of the deep sea deposits. Weil Thomson wrote a book titled Voyage of the Challenger, the Atlantic. This treatise included various aspects of the oceans, namely the vivid description of the Sargasso Sea, the morphology of the ocean bottoms, the origin and deposits of the deep ocean basins, the distribution of the seawater temperatures, measurements of the ocean currents, and the physical chemical characteristics of the ocean water, etc. Besides, Weil Thomson also published the weather conditions, the analysis of the pelagic muds and various other marine deposits, and the description of a large number of marine plants and animals. The results of the investigations by this expedition were published in 50 volumes covering thousands of pages. For biological investigations, this expedition has no parallel. However, in the absence of any physicist in the team of the scientists aboard the ship, the special study of water circulation system of the ocean could not be made. Fridtjof Nansen, Dr. Nansen, who is Norwegian explorer who had keen interest in exploring the North Atlantic in the polar area. He took great help from the results of the earlier attempts to explore the polar area during the second half of the 19th century. He, with a crew of 13 men, began his voyage on a specially built small ship, Fram, which was so designed as to be free of the grip of the ice sheets, so common in the Arctic seas. His ambition was to transport an expedition across the North Pole. The design of the Fram proved to be successful. Ice sheets could not hinder its progress. However, the ship was captured by ice at a latitude of 78 degrees 30 minutes north, about 1100 kilometers from the North Pole. Ultimately, Nansen left Fram and, accompanied by F. Johnson, made an attempt to reach the North Pole by dog sledge. But Nansen failed to reach the 90 degree north latitude and could reach a point of 364 kilometers from the pole. Both of these men, Nansen and his companion, returned to Norway on the English ship Windward on August 13, 1896. During this expedition, it was proved that no continent existed in the Northern Ocean. It was also found that ice covering the polar area all the year round was just a freely moving pack ice accumulation formed directly upon the ocean surface. The depth of the ocean was much more than 3000 meters and the temperature was as high as 1.5 degrees Celsius between the depths of 150 to 900 meters. Nansen described this water as a mass of Atlantic water lying below the less saline Arctic water. The 20th century witnessed an unprecedented growth in the field of the oceanography. It should be borne in mind that the oceans are three-dimensional. The study of their horizontal extent may be relatively an easy task, but the studies of the physical, chemical and organic properties of the seawater in depth is rather very difficult. For the systematic scientific study of the oceans, the accurate knowledge of morphology, structure and the deposits of their flow is essential. There is little doubt that in the earlier period, various expeditions were organized for the investigation to the secrets of the oceans. It is also true that the eminent scientists and adventurous explorers participated in those expeditions. But due to the lack of improved technology and modern equipments, those expeditions failed to achieve the desired goal. Voyage of the Meteor. Practically a new era dawned with the Voyage of the Meteor from 1925 to 1927 with the German explorers aboard. This expedition party for the first time used echo sounders, making it possible to obtain a continuous depth recording as the vessel proceeded along its course. The Meteor gathered data 24 hours for a period of 25 months. This expedition was concerned mainly with increasing the knowledge of South Atlantic Ocean. The Meteor expedition made some 70,000 soundings of the ocean depths. In fact, this expedition for the first time displayed true rugged nature of the seafloor. The most important event in the story of the development and oceanographic research happens to be the organization of the International Geophysical Year in 1957 to 1958. In the geophysical year, at least 70 nations along with a large number of international scientific institutions worked together and ensured their active participation in it. Encouraged by the measure of success achieved, the International Geophysical Year continued its assignments with the help of International Geophysical Corporation till 1959. During those 2 years, observational data were collected from thousands of stations. Motivated by the scientific program, another project, namely the International Indian Ocean Expedition, was started. During this period of 5 years, from 1960 to 1965, 27 nations participated in the oceanographic investigation program of the Indian Ocean. In this expedition, more attention was diverted to the Arabian Sea and the Bay of Bengal. Remember that under the auspices of the International Indian Ocean Expedition, an Oceanographic Institute was established in New Delhi, and also it led to the beginning of the oceanographic research in India. More than 20 countries, including India, participated in the internationally sponsored Monsoon Expedition, or the MONEX, and 38 research vessels were actively engaged in the Indian Ocean. In the North Indian Ocean, investigation work was done in the area extending from 60° east longitude to the coastal waters of Sumatra. With the establishment of the World Meteorological Organization, that is the WMO, in 1950, many more scientific organizations were formed. An independent technical commission was established, and its activities contributed largely to the development of oceanography. Later on, in 1967, World Meteorological Organization embarked upon a very ambitious program called the Global Atmospheric Research Program. In the materialization of this program, full cooperation was received from the International Council of Scientific Unions. This program did commendable work to increase our knowledge concerning all the oceans in the southern hemisphere. Needless to say that in the development of the modern oceanography, the contributions made by United Kingdom, France, Germany, Japan, India, Belgium, Canada, Norway and Sweden were most valuable. The National Aeronautics and Space Administration, NASA, organized in 1958, has been playing an expanding role in the marine science. In 1978, NASA's 𝗬Sat, the first oceanographic satellite, sent oceanographic data to the Earth continuously for 4 months. More recent contributions have been made by satellites sending radar signals of the sea surface to determine wave height, variations in the levels of the sea surface, and the temperature, and many more. Information of the interest to the oceanographers. However, in 1992, the first of the new series of the oceanographic satellite was launched jointly by NASA and the Centre National des Études Spatiales, the French space agency. The centerpiece of 𝗂𝗶𝗃 or Poseidon is a satellite orbiting 1336 kilometers above the Earth in the orbit that allows coverage of 95% of the ice-free ocean every 10 days. The satellite is equipped with latest devices such as positioning device, radar transmitters and other such ultra-modern devices which would facilitate the research work of the modern scientists. Besides, Russia, China, Japan, France and other countries in the world have their own interest in the oceans and are making their contributions in furtherance of the marine science. Now, different nations are taking active interest in the oceanographic research and are organizing expeditions. Our own country, India, has during the last few years sent many expeditions to Antarctica, and it succeeded in establishing a permanent oceanographic research laboratory on the cold continent. These expeditions have contributed a lot to the development of the modern oceanography. At present, artificial satellites have been pressed into service to discover the hitherto unknown parts of the world ocean. Computers have proved to be of immense value in the difficult task of oceanographic research. Let us hope that in the near future, man will be able to unfold the mysteries of the oceans.